Hello friends, very good morning. A hearty welcome to my YouTube channel. Myself Dr. M.H. Annaya. In today's video, we are going to work out a problem on the development of a pentagonal pyramid which is resting on its base on HP with one of the base edges normal to VP, and this is being cut by a section plane which is normal to VP and no and it's normal to VP and parallel to one of the triangular faces. So friends, for this particular position, one of the triangular faces of the lateral surface of the pyramid should come to your right side or to your left side, because this triangular face should have 3 points. So initially we have to place the object on HP such that one of the shorter edges of the base is perpendicular to VP and obtain its projections, namely the top view and front view. Friends, here I have constructed triangle of side 30 mm. I will the one of these sides, say this side normal to VP, and I will call this side as AB and mark the remaining as C, D and E. O is the apex, O dash is the apex in the front view. Now friend, this is being cut by a section plane which is normal to VP. The section plane is normal to VP, and hence it will be seen very obviously as a line in the front view and parallel to one of the triangular faces. Before that, let me complete this marking. So if you project the lines from here, you get this point as A dash, B dash, this is O1 dash, this is C dash, E dash, this is D dash. So this is the front view of the solid, this is the top view of the solid. Here OA, OB, OC, OD, etc. represents the top views of the slant edges of the pyramid. Now friends, let us mark the section plane next. The section plane is perpendicular to VP, inclined to HP or parallel to one of these end slant edges. So friends, at what distance? It is at a distance of 8 millimeter from it. So friends, I am going to mark a line here representing the section plane of the solid at a distance of 8 millimeter from that last line. So what that last line represent? This last line O dash, A dash, B dash has got 3 points. Hence it represents a triangular face. And this section plane SES is normal to VP and parallel to this triangular face O dash, A dash, B dash. And friends, we are going to say retain this part of the solid, and the remaining part of the solid is removed. So this is the part for which we are required to draw the development. And friends, you know very well that always the developments are drawn to the actual size or the true size of the solid. Here friends, we have got 5 slant edges, O dash, A dash, O dash, B dash, etc. And if you observe the front view of the solid, you find that this slant edge O dash, D dash, which is represented by OD in the top view, is parallel to VP, and hence this will give you the true length. I will mark it as true length somewhere here. This will give you true length. Now friends, taking this length as the radius, I am going to draw a sector here on which I am going to mark 5 steps AB, BC, CD, DE and EA, each of 30 millimeter. 30, 30, this is 30, 30 and finally this is 30. And next comes marking of the starting point of this development. Friends, here if you observe the front view, O dash, A dash, O dash, B dash are totally removed after the solid is cut by the section plane. Hence, we have to commence the development either from OA or from OB only. So, I am going to start with say A. This is A, this is B, C, D, E and again A. This is C, D, this point is E. So we have drawn this development. assuming that the solid is not cut by any section plane. Now we'll have to go to front view and see where all the solid is being cut. Friends, if you observe here, this section plane SS is cutting the base. This line represents the base. So where it is cutting, friends, you can see here, this is cutting the solid at this point and again at this point. So it is cutting at 2 points, namely the base edges AE and also BC. They are cut. So how to locate that? All these dimensions are true length. So on AE nearer to A, you take this distance. On AE nearer to A, you have this distance. Next, you have got on BC nearer to B. On BC nearer to B, you have this distance. Next, friends, it is cutting the slant edges OC and OE here, but OC and OE are not the true length. Hence, I am going to shift that to the true length line and obtain that measurement on what is called OC and OE. It goes up. So this is 1 point on OC, 1 point on OE. We have got this point. Finally, O dash D dash is cut here. This is the true length. Simply you can mark this distance on the slanted OD. So this is how you will get, friends. Now, friends, for all the pyramids, cubes and prisms, we have to join all the points so obtained by straight line. Hence, friends, I am going to join these points like this. Straight line from here, straight line, again straight line from here. And friends, it is a pyramid, and here OA, OB are totally removed, and hence in the development these three lines do not exist, OA, OA and OB. And friends, then we have what is called this part. When this is not existing, this is also not existing. And here again this part is not existing. And friends, if you just see the base edges, this part is retained. Hence I am going to join this by straight line like this. All by straight line and up to here right. And friends, these are all the edges that are retained. So I am going to mark this by straight line. Again this edge by straight line, this edge by straight line. Friends, this is how we obtain the development of this part P of the pyramid, which is being cut by a section plane which is normal to VP and parallel to the triangular face O dash, A dash, B dash. So I'll write down here, this is the part, this portion is the development of P, the lateral surface of the larger part of the pyramid. Friends, I hope the presentation was interesting. If you like this video, do share the information about this video and have a wonderful day. I thank you very much for watching my YouTube video.